Okay, good afternoon, class. So at this point we're looking at sequence and series. We're on exercise 7. That was the homework, no? Right. So I'm going to pause the video here. We're going to run through sigma. For those of you who want the full lesson, it will be found in the description box below. Okay. Alright, so at this point, we spoke about how sigma works and all of those things. Again, if you are confused on sigma itself, you can refer to this description box below. Okay. So now we're looking at example 1. Example 1 is on page 18. Right, and these are the examples for exercise. These are the examples for exercise what? In the, exercise 8 is on page 20. Okay. So let's go. Here we are told to work example 1. Evaluate. People evaluate, calculate, determine. It's all the same thing to us. Okay. Sigma starting at -4 or ranging to 20 for a general term 5n minus 2. Again, just to refresh your memory, we're saying that that's your starting point, your ending point, your general term is equal to the sum of terms. How do we calculate the number of terms in the series? The end point minus starting point plus 1. Right. Let's go. Whenever we're given sigma, what do? We work out the first 3 terms. Okay, so what we do is, we say we're starting at, where do we start? -4. So it's going to be 5 times -4 minus 2. Not so. Plus. What's the next number? -3. We just go with +1 all the time. Okay? Which is -3. So it's 5 times -3 minus 2. What's the next one? -2. So it's 5 times -2 minus 2 plus and so on. If you wanted to use the second sum of formula, then I would have just calculated the first term and the last term, because as you can see it's arithmetic, not so. But we just make it general, and we just work out the first 3 terms. Okay. But if you're that kind of girl that want to be a bit different, take over the world and so on, you can work out the last term, and as Aaron knows we're talking about that. Alright. But here we go. What do we have here? It's going to be -22. Not so. What is this second term going to be? -17. The next one? -12 and negative and so on. So those are my first 3 terms. What is the A value? What's your first term? -22, which is my A value for the formula. Not so. What's my common difference? +5. So that's my what value? The D value. People, how many terms are here in the sequence? N is equal to the end point minus the starting point plus 1. So it's going to be 20 minus -4 plus 1, which gives us what? 25. So work out the sum of 25 terms using the formula n over 2, get 2a plus n minus 1. Why am I going with this formula? Because sigma stands for sum of. You guys understand? Huh? Can I explain again? Okay. So just do that quickly. Pause the video at this point. Okay, so some of the learners say they don't understand what's happening, so we're going to go try again. Okay. Alright, so you have a look quickly, people. Right, maybe I think it's the red pen. Let's go with black. Right. So where do we start? We start with the ending point, which is -4. So what do we say? It's going to be 5. Whenever we're working sigma, we work out the first 3 terms, always. Okay. So we're going to say 5 times -4 minus 2. That's term 1. What's the next term? Term 2, which is -4 plus 1 is going to give you -3. So it's 5 times -3 minus 2. What's the next term? 5 times negative 2 minus 2, and so on. Okay. Remember, this is term 1, term 2, term 3. You all with me? Right. So what does this give us? Negative 22, negative. Now, negative 15 minus 2 is negative 17. Negative 10 minus 2 is negative 12. Minus and so on. I could have put plus, doesn't matter. Will you guys understand? Alright. Don't tell me now at the end you don't understand, huh? That I can see what the issue is. Alright. So the first term is negative 22. What's your A value? Negative 2. We've got negative 2, negative 17, negative 12. So what's my D value? Plus 5. What does sigma stand for? Sn, sum of. That is why I wrote down the formula. Sn is equal to n over 2 into 2a plus n minus 1. I know what A is, I know what D is. What do I need still? N. So how do you work out N? It's ending point, which is 20 minus starting point, negative 4 plus 1, which is 20. So I'm going to work out the sum for 25 terms. Not so? Just do it in front. Are you guys okay? Right, so let's go. Sum of 25 terms. It's 25 over 2 into 2. What's your A value? Negative 22 plus 25 minus 1 is 24 times D, which is 5. And some of you worked it out? 950 big ones. Right. People, is there any confusion? You all okay? You still need to write down, or you gonna carry on? Carry on, okay? This is example 2. Example 2 is on page 18. 19. Okay. Listen, man, I don't know. I will take your word for it. No reason to scale. Right. Exercise 2, page 90. Where do we start? It says evaluate, determine, calculate. It's the same to us. Okay. Simplify. Did I say simplify? It's also the same. Okay. What do we notice here? It's starting at n and it's going all the way to infinity. So what are we going to calculate here? Sum to infinity. That's it. But what's the first thing we need to do? We're going to work out the first 3 terms. Term 1, 2, and 3. So Goliath, you are right in a way. No? You are answering the question before I could have asked. So what are you going to, so to work out the first 3 terms, what do I say? So I start at 1. So it's 3 into of 1 minus 1. You all agree with that? Plus, what will the next term be? 3 times of 2 minus 1 plus 3 times of 3 minus 1. If I had gone to the next one, what would it have been? 3 times a half to the exponent, 4 minus 1. What would the next one then be? 3 times a half, 5 minus 1, and so on and so on and so on. Okay. Would I calculate how many terms you are? No, why? Because we know it's going to infinity. We can check. The ending point, whoops, minus the starting point plus 1, which is infinity. Yeah? Even if you start at 0, it will still be infinite. Or at minus 1, still be infinite. You guys understand? So what is the sum to infinity formula? Is it going to be A over 1 minus R? What is my A value? 3 into R to the 0, which is 3. Not so? Let's move to the power 0, so it becomes 1. So that is 3. Plus 3 over 2. Plus 3 over 4. Plus and so on. Am I moving too fast? Do you guys understand? Yes, Nika, you're rubbing your temples. Are you okay? You understand? Yeah. So what is your A value? 3 over 1 minus, and what's my R value? A half, yes, because that's 3 over 2 divided by 3. So it's half. So my answer is 6. Right, you guys understand? So do it again. No. Ciara, you alright? Why are you laughing? You want to be a clown? Huh? How can you be scared of me laughing all the time? Right. People, example 3 is on page 19. You all agree with this? Right. I'm going to give you a chance now to breathe quickly. So pause the video. Sort Ciara out. Right, so where do we start? We start with the first 3 terms. So we start where R is 1. So it's going to be a half into 3 to the 1 minus 1 plus a half into 3 minus 2 minus 1 plus a half into 3 to the 3 minus 1 plus and so on. Okay. So that's going to give us half plus 3 over 2 plus 9 over 2 plus and so on. How many terms are here? Number of terms is going to be n minus n plus 1, which is n. So this is n amount of terms. It won't always be n. Could be n plus 2 or n minus 1, whatever, depending on the starting point. Okay? Who's confused? Nobody yet. Okay. People, what does sigma stand for? Sum of. So this here is equal to Sn. So what does that mean? That means to say that the sum of the series is equal to 1640. You guys understand? Right, so let's go with that quickly. So n is equal to AP or GP? GP. So it's A or n minus 1 over R minus 1. So what is Sn equal to? 1640 is equal to A 1 over 2 R 3. N is unknown. Minus 1 over 3 minus 1. Not so? Right. Now what? So we have 1060. 1640 is equal to. Now a half divided by 2 is a quarter. 3n minus 1. So how do I get rid of a quarter? Divide by quarter or multiply 1640 divided by a quarter. It's going to give you 6560. 6560 equals 3n minus 1. Now what do we do? Take 1 over. So it's 3 to the n is equal to 6561. Don't use your brain at this point of the day. No? So now we say shift to factorize. So it's 3 to the 8. So 3 to the n is equal to 3 to the 8. Therefore, n is equal to. So just going back here, we didn't even read the question. Determine the value of n. We just want to do maths, we don't want to read, no? So n is equal to 8. Do you guys understand? Right. Listen. I'm going to pause this video here. So for homework, listen. So I'm going to pause the video at this point. Tomorrow I won't be here, so don't get excited. Right? However, you guys are going to download the video Example 4 is tomorrow's work. So this afternoon you can download it. Tomorrow during your maths lesson, whoever is going to invigilate you guys, you can watch a video in that lesson. And you can then answer the rest of the homework. Just hang on. So for homework, it is exercise 5. Which exercise are we on? Oh, sorry. I would say it looks a bit easy. Yeah, it's exercise 8. Okay? So whatever you can't answer from exercise 8, please watch the rest of the video, and then you should be able to answer exercise 8. People enjoy the rest of your day.
Please 12A, can please report to Miss.
Okay, so now we're looking at example 4, and example 4 is on page 20. Example 4 is on page 20. So they ask you to evaluate each of the series below and express the result in sigma notation. So we spoke about what sigma is and how it's basically laid out. Just a reminder for those of you who are a bit dodgy on it. In sigma, we'll have our starting point, ending point, the general term is equal to the sum of terms. Okay. So looking at number 1. So when we set up sigma, we always start at 1. Okay? We need to know how many terms there are. We need to work out the general term, and we work out the sum of the series. Okay? So the general term would be Tn is equal to a plus n minus 1t. How do I know it's arithmetic? Because I'm subtracting 8 all the time. So we got 12 plus n minus 1 times negative 8. So there's negative 8n plus 20. So that's a general term. Okay. Now remembering this is the nth term, the last term. Okay. If I set that equal to the general term, in turn I will determine how many terms there are in the series. So I now say negative 276 is equal to negative 8n plus 20. So 8n is equal to 296. Okay. So I say 296 divided by 8 gives you 37. Which in turn means to say there are 37 terms in the series. So n is equal to 37. Right. So we got the general term, we know how many terms there are in the sequence. So now I must just work out Sn. So the sum of terms, okay, do I have the last term? Yes. So I go n over 2 into a plus. Otherwise I could have used the formula n over 2 into 2a plus n minus 1t. So I'm working out the sum of 37 terms. It's 37 over 2 into a, which is 12 plus negative 276. Okay. So that gives us 37 over 2 into 12 minus 276. Alright, so it's negative 4,884. Okay. So again, we are given the series. We work out our general term. We set the general term equal to the last term. With that, we will be able to determine the number of terms, which is 37. And then since they want you to evaluate the series, you must then calculate the sum of the 37 terms of the series. Okay. But have you answered the question in total? No? They ask us to write it in sigma notation as well. So to write it in sigma notation, our starting point, we always start with n is equal to 1. The starting point is 1. We have 37 terms. Our general term is going to be negative 8n plus 20, and it's equal to the sum of terms, which is negative 4,884. Okay. Let's look at the next example. This is still from example 2, but it's number 2. Example 4, number 2. So here we got 100, we got 40, we got 16. And remember, for sigma, the starting point, ending point, the general term is equal to the sum of terms. Okay. So the general term we must first work out. So Tn is equal to, how do we move from one term to the next? It's 16 over 40. 16 over 40, which is 2 over 5, or 40 over 100, which is 2 over 5. Okay. So the R value is going to be 2 over 5 here. So we got A, R, n minus 1. A, R, n minus 1. Your A value, of course, is 100. R is 2 over 5. Okay. So that's 2 over 5 raised to exponent n minus 1. Can we multiply this 100 and this 2 over 5? No, because of that unknown exponent there. Okay, so that's my general term. Since it's carrying on forever, it's going to go to the sum to infinity. So when we're going to work out the sum of the series, I'm going to work out sum to infinity. So that's equal to A over 1 minus 1. As you can see as well, R is lying between negative 1 and 1, which means to say the sum of terms would be, of course, will allow you to work out the sum to infinity. Okay, so my A value, of course, it's the 100 over 1 minus R, which is 2 over 5. Okay, so that we can work out. So that is simply going to be 100 over, there's 500 over 3, I think. Let's check. There's 1 minus 2 over 3, over 5, sorry. There's 500 over 3. Make that correct, okay? 500 over 3. But have I answered the question? No? They wanted you to write it in sigma notation. So we start again when n is equal to 1. And it's carrying on to infinity, the sum to infinity. Your general formula, Tn, so Tn is going to be 100 into 2 over 5 n minus 1 is equal to the sum of terms, which is 500 over 3. Okay. That's the answer they're looking for by writing it in sigma notation. Okay. So what I'm going to do is I'm going to move this up. I'm going to delete this. And run out of space here. Let's pull this up. Okay, this is example 4. It's on page 20. Okay. Example 4, page 20, number 3. As you can see here, we know what the last term is again. Okay? So this is going to be, how do I move from one term to the next? I'm multiplying it by negative 2. Okay, so it's a geometric. So again, sigma, the starting point, ending point, general term is equal to sum of terms. Okay. So the general term is Tn is equal to AR n minus 1. So A value, of course, is going to be 5. R is negative 2 raised to the exponent n minus 1. That's my general term. So that is your nth term. So I want to calculate how many terms you are. So you're going to say 5,120 is equal to 5 into negative 2. So I'm going to pause the video here and do a line the board again. Sorry about that. It's just jumping all over the place. Let's just try again. So that's going to be 5,120 is equal to 5 into negative 2 n minus 1. Okay. So that would give us, we divide by 5 both sides first. So that will give us 5,120 divided by 5 is a 1024. So it's 1024 is equal to negative 2 raised to the exponent n minus 1. So as you can see, the basis should be the same, so of course that has to be negative 2 to some exponent. However, that exponent has to be even. As you can see, 1024 is a positive number. So you say shift, factorize is 2 to the 10. Yes, as you can see, the exponent is even. So we can say therefore, that is going to be, therefore, 10 is equal to n minus 1, so n is equal to 11. Which means to say there are 11 terms in the sequence. Okay. So what I'm going to do is I'm going to take this off here. I'm going to work out the sum of the sequence. Since it's geometric, it follows the sequence Sn is equal to A R n minus 1 over R minus 1. Or I could use the other formula. So S11 is equal to A, which is 5 into negative 2, 11 minus 1 over negative 2 minus 1. Okay. So that gives us 5, open brackets, is negative 2 to the exponent 11 minus 1 over negative 2 minus 1. That gives you 3,415. 3,450. 3,450. But remember the question was to work out or to write it or represent it in sigma notation. So we go sigma, starting point as we said, n will always be 1 if we write it up ourselves. How many terms are here? Of course 11 is the general term, which is 5 into negative 2 raised to the n minus 1 is equal to 3,415. Okay. Again, you can't multiply this here because of the exponent, the variable exponent on the 2. Alright. Last one. Again, I need a space. If you need, you can pause the video at this point. Otherwise, I'm just going to delete this. Example 4. It's on page 20. Yes. Out of example 4, this is number 4. Okay, this pattern is a bit different. So here there are 1, 2, 3, 4, 5, 6, 7 terms. So if I go with sigma, we know there are 7 terms if n is equal to 1. Let's work out the general term. What you notice here is, once I move from one term to the next, I'm adding 3, then 5, then 7, then 9, then 11, then and so on. So in other words, it has a second common difference which makes this arithmetic. That's quadratic. But you could have said, it's easy to see that the general term is squared numbers. You could have just written n squared. For those of you who didn't see it, you must first go to a is equal to 3a plus b, a plus b plus c. Is it necessary? No. Okay, as you can see, it's fairly simple. So the general term is going to be n squared. Okay, the sum of terms. So I'm going to say the sum of 7 terms is going to be 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. Okay, that is going to give us 50. Right, that is 40. So 50 plus 40 plus 9 plus 16 is 25, so it's 50. So that's going to give us 140. Okay, did I have to do that in my head? No, of course not. You just use the calculator. Okay. So if you write that in sigma notation, so it's going to be n squared, remember the general term is equal to the sum of terms, which is 140. And that's the answer they're looking for. Okay. So with that, you should be able to do the whole of exercise 8, which is on page 20. Okay. Sorry about this long video. If you want the full lesson, it will be found in the description box below.